Good morning, everyone. Sorry for the late. I hope everybody is here. Like, uh, there was a small problem with the internet that I have been encountered. So that is the reason why I was not able to. Yes. Yeah. So good morning to everyone once again. Sir, I got negative marks in yesterday's test. Don't worry about my dear Sandeep. So that is not directly. First of all, so I got to know that around 70% of the students have done this test. Not 70, 65 something, 65 to 70% of the students have done this test, and within a short time, I'll be getting the results, and I'm going to display those results also. So wait for that. But as of now, let's see in yesterday's class. Yes. See, in yesterday's class, we have been discussing possibility characteristics like AV. I hope everybody is able to listen, and my voice is clear to all of you. I hope so. Mr. Sachin, I have seen your mail, and so don't worry. Yesterday in examination with two silly mistakes, my score dropped from 25 to 20. Was burning like anything, thinking I'll repeat the same. See, my dear Anonymous, you don't need to worry about that. Actually, it happens every time. It happens. So whatever the people, they know all the topics, they know all the concepts, but minor mistakes they do while converting the units or solving or rounding off, there is a problem with that. So over the period of time, you can rectify that. You don't need to worry about. So not think about the same way in final examination. You have a lot to go. Yes, one more thing, my dear West Bengal, whoever staying in West Bengal and Odisha coastal people, one of our anonymous attendee is saying that West Bengal and Odisha coastal people be safe. Cyclone Amphan will hit in the afternoon or in the evening, and the people who are staying in the coastal areas and especially this is going to be hit on the this is going to be hit on the Odisha and West Bengal. So you people whoever are there near to those coastal areas, be safe. Sir, I made mistake in two questions due to virtual calculator. How to get used to it? No shortcuts, Mr. Nikhil. The only way is practice, practice, practice. That's it. See, yesterday how I have given you the paper, the same way the examination paper would be there. I already mentioned you 33%, very easy, 33% medium, and the remaining 33% is going to be typical topics where I have given some logics inside of that. So some of us got only 25 minutes test automatically closed after 25 minutes. You don't need to worry. I have said to the technical staff team, they have taken care of all those things. So don't worry about that. How to avoid silly mistakes? Practice, practice, practice. So can you explain the yesterday's test questions? No, I have given a detailed solutions for those, so I'm not going to explain those. Time is very less. No, my dear Rishikesh, it's not time is very less. Actually, in a GATE examination, total 65 questions would be there. And 65 questions, the time is going to be 3 hours. I have given you 20 questions, so the time is 1 hour. Okay. Yes. Thank you for your teaching. I got first rank. Congratulations, my dear. Due to this time, I even couldn't see the remaining questions. See, I'll be taking a small session today after the class. Means after the class means during the class. How to avoid the tension. So just wait for that. I'll be taking a small session regarding to that. But now, so I got only 25 minutes. Okay, now I got to know that some of the students were saying it 25 minutes. See, that's for IES students it was there. I think that for all the IES students the time was 25 minutes. I think so, because in the case of the IES, whatever the total number of questions are, how many? 150 questions, and how much time they are going to give to you? 3 hours. 3 hours means 180 minutes. So 150 questions and 180 minutes. Similar way, 20 questions are 25 minutes. See, for the IES people, it was a 25 minutes. So for the remaining GATE people, it was 60 minutes. And the ranking for the IES was separate and the GATE was separate. I have prepared the question paper for IES in such a way, all the MCQs, and for the GATE numericals and MCQs. So the examination was conducted with the same paper, but with the MCQs in the case of IES, with the numericals in the case of the GATE. I have already provided yesterday's solution, so you please go through that. See, I gave you the questions in such a way, I know where you will go to the mistakes. I know it, where you went the mistakes, mainly during the conversion of the units, using a small formulas, and I have given unnecessary data also sometimes. So it's about fooling you means make you to make sure which is actually necessary for you. Okay, fine. Now let's start our session. It's already been late. Very good morning. I'm working employee. Please consider as okay, fine. So from next week onwards, I'll be letting you know before 1 week to prepare for the examination. See, I'm telling you one more thing over here. Uh, yes. See, now we are in our 11th chapter. Yes. So I think so. Within 10 days, there would be one more test. So you please be prepared from now itself. You please be prepared for now itself. I'm going to conduct 2 more tests. So next test would be on the from chapter number 11 to chapter number 20. Next test would be on chapter number 11 to chapter number 20. And after 3 days of those tests, I'm going to conduct a grand test on the geotech. So you please remember to this, and you please study according to that. Yes. So now let's start into the session. Announce the top 10. No, I did not. I will announce. I'll announce. So within a short period of time, I would be getting a file so that yes, I did not got it. Once I got it, I'll be letting you know. But as of now let's start our session, please. So now, yesterday, before going to that, yesterday I discussed you different type of compressibility characteristics. We discussed about AV, we discussed about CC, and I explained you what is the difference between the AV and CC, and then we discussed about how to determine the ultimate settlement, and I told you give importance to CC equation out of all, and then I have explained you a question also. So from our classroom practice questions, we have discussed about the questions, and yes, and then we discussed about the soils based on the stress history. So I told you NCC, OCC, and UCC. Now I'm going to show you everything in a graph. So have a look over there. Normally consolidated clay. What is mean by normally consolidated clay? When the present stress acting on the soil is more than the past stress, then it is going to be normally consolidated clay. Normally consolidated clay. Okay. And when do you say over consolidated clay? When the soil got consolidated under past stress and the present stress is greater than the past stress is greater than the present stress, then we call it as over consolidated clay. And what do you mean by UCC? UCC means present stress is more than the past stress. Present stress is more than the past stress, but the maximum stress has not reached yet. Then we call it as a UCC. So now, how I'm going to explain all these three. How I'm going to means how we are going to get all these three. So we are going to call it as cyclic loading, or loading and unloading. Cyclic loading or loading and unloading. So far I have discussed you what happens when you load. Now I am going to discuss you what happens if you load and unload. So now let's see, listen to these conditions clearly. Do not try to ask any questions in between. If you try to ask any questions in between, you will be in the losing side because you will be missing some points. So listen to the points clearly. Already you know this. Now I'm going to define in a different way. Now, from the E versus from the E versus sigma dash graph. This is sigma dash and this is going to be E. So yesterday I have given you E versus a sigma dash graph. Yes. So from the E versus sigma dash graph, you got the compression curve and the slope of the compression curve is going to be coefficient of compressibility. Yes or no? Now let's go back to the same thing. So let's take here initially sigma naught dash. What is meant by sigma naught dash? Initial over burden pressure. So you know it. Again, I am writing over here sigma naught dash initial over burden pressure. Initial over burden pressure. So now for the sigma naught dash, definitely there must be some void ratio. Let's take it as a E naught. Let's take it as E naught. Definitely there must be some initial void ratio. Let's take it as a E naught. Now, you know, when you apply a load, first of all, I'm discussing about loading. When you apply a load, what happens? Immediately, entire external pressure will be taken by whom? Water. And as the water starts to dissipate, then the effective stress starts to increase. When the effective stress starts to increase, void ratio starts to decrease. Yes or no? Void ratio starts to decrease. Now, void ratio, you observe over here, void ratio starts to decreases and reaches to this point. Void ratio starts to decrease and reaches to this point. So now everybody, this is the initial void ratio and this is the initial effective stress, which is nothing but initial overburden pressure. Okay. So can I say this is nothing but a loading curve or compression curve? Compression curve, which is going to be loading curve. So now you see, you observe over here, by the time you reaches over here, what is this present stress? This is the present stress. What is the present stress? This is the present stress. And what is the past stress? This is the past stress. Whenever the present stress is more than the past stress, whenever the present stress is more than past stress, greater than past stress, what do we call? NCC. So we call that soil as a NCC. Now, if you observe clearly, this is the present stress. So this is the past stress. As the stress is going to be increases, now can I say the soil is under which condition? NCC or OCC? Now this soil is under NCC. This is the first loading. Okay, this is the first loading. Now, when I apply the load and when I remove the load, when I apply the load and remove the load and apply loading again. So now you see, I need to remove the load. When I remove the load, what happens? Think about that. Array, this is a one structure. This is initial overburden pressure. So I will be explaining those things here also. Now, you please have a look. Yes, this is a ground level, and let's take this is a clay layer. At the center of the clay layer, and this is sigma naught dash. What is meant by sigma naught dash? Initial overburden pressure. Now you constructed a home. Now you constructed a home like this. Yes. So when you construct a home, definitely the stressor due to the external load will be increases or not? Delta sigma dash due to this one. This is external load. Yes or no? So now due to this external load, the soil will undergo compression and the void ratio reduces from E0 to this point. This is the void ratio. Now what happens is I am going to remove the load. When I remove the load, observe, I will erase this entire, means I will demolish the structure. When I demolish the structure, then what is the present stress now again? When I demolish the structure, what is the present stress again? The present stress is going to be sigma naught dash. Yes or no? When the present stress is going to be C, now if I remove the load from here to here, do you think the void ratio will remain same, or it will regains to E0, or it will regains to some portion? Think and say. Now my question is, when you remove the load, do you think the void ratio will regains to initial void ratio or less than that? Definitely less than that. You see, earlier this is the ground level. Now you observe here, again I am drawing. Please listen to this point. This is a structure, and due to this structure, definitely the ground level the ground level, this is A and this is B, the ground level will subside. Yes or no? Now when I remove the load, the ground, see, once the ground is going to be consolidated settlement, now it tries to regain its shape. Yes or no? Now, my dear students, do you think once the volume is going to be reduces, do you think it is going to be regains completely or partially? It is going to be regained very less amount. Now this is C. First, A to B due to loading, B to C due to unloading. This is due to whom? Loading. And this is due to whom? Unloading. So due to unloading, the soil will not reach its initial position, but it tries to reach somewhere over here. Now, if I draw, can I say this curve is going to be the unloading curve? This is known as unloading. So when I remove the loading, if you observe, when I remove the loading, now the soil will try to regain its original position, but it won't. It will regain a very little bit amount over here. It will regain very little bit amount over here. So let's take E1, E0. Now it is going to be E1 here, and then it is going to be E dash. I hope you understood the point over here. Now, so this is the loading curve and this is the unloading curve. Let me represent the yes. Now this is unloading. So for the unloading, now can you please tell me, this is going to be the present stress, this is going to be the past stress. Yes or no? See, let's say initially the sigma naught dash is going to be some 50 kilopascals. Okay, let's say. And initially you applied sigma dash of 100 kilopascals, which means somewhere over here, let's say it is going to be 100 kilopascals. Now you applied a load of 100 kilopascals. When you applied a load of 100 kilopascals, the soil will undergo deformation over here. So this is the 100 over here. Now the soil has been experienced. What is the pressure? 100. But what is initial? 50. Present 100. Present is more than the past. Then we can call it as a NCC. Now, when I remove the load, after removing the load, again this 100 will be changes to whom? 50. So from 100 to again it is going to be 50. Now, already what is the past stress? Now after loading, after removing the load, what is the stress over here? When I remove the load, then the stress is going to be, means here is going to be sigma naught dash only. But what is the previous stress over here? The previous stress is going to be 100 kilopascals. So now, can I say, when I remove the load, this is the present stress, this is the past stress, because from here only it came or not? Present sigma naught dash, past this one. So this is the stress where the soil is pre-consolidated or not? This is the stress where the soil is going to be pre-consolidated. So now I can write this one as sigma C dash pre-consolidated pressure. Pre-consolidated pressure. Now this one, whatever I am representing, I am going to say it as pre-consolidation pressure. Why, sir? When you remove the load, sir, what is the last load that the soil has been undergone consolidation? This is the pressure. Yes or no? So now, in the case of the NCC, the present and the pre-consolidation both are same. So OCR is equals to 1. Yes. And in the case of the OCC, the present is going to be here, past is going to be here, past is more than the present, OCC is greater than 1. Now, when I apply the loading again, this is unloading. When I apply the loading again, so now you start to apply the load. See, first loading and then unloading. Now you apply the load again. By the time you reaches over here, already soil undergoes some compression or not. Now, due to this, you see, this is the point I am representing you. Yes, this is the present stress. This is the past stress. This is the present stress. This is the past stress. Past greater than present, we call it as OCC. Yes or no? I hope you understood the point over here. Past greater than present, OCC. After unloading and you load, now this is the present, this is the past. Now the soil is under which state? OCC. And slowly, it reaches to this point. Now I can say this curve as a recompression curve. What is this? Recompression curve. See, what is this? This is a compression curve and this is going to be the recompression curve. Yes. Now this soil is going to be OCC. This soil is going to be OCC. So you observe, first I loaded the soil from here. This is the first loading, first time loading. If a soil has been subjected to loading for the first time, then you are going to call it as NCC. Now when you remove the load, now this is the position. Soil already has been experienced sigma C dash R naught. Now after you reload it at this position, this is the present stress I am showing you. This is the past stress. When do you say OCC? When the past stress is more than present. Up to this point, the soil will behave like a OCC. And then, now, from here onwards, From here onwards, if you observe, now I am loading. Now my load is at this point. Now this is going to be the present. Now this is going to be the present. What is the past? This is a sigma c dash. Again, you tell me now. The present is more or past is more? Present is going to be more. Simple point I am just looking over here is present, past. Present and past. So now I am applying loading further and the present stress is going to be more than the past. Now the soil starts to consolidate under present or not. From here onwards, the curve is going to be again shift. Now this is going to be UCC. What is mean by UCC? What is mean by UCC? I have explained all those things. See what is mean by UCC? You observe, soil has subjected to present stress more than the past stress, but the maximum stress has not reached yet, which means during the stage of construction. So now what I do is observe. See, this is the present, this is the past. Now the soil is under the consolidation UCC. Now let's take the soil has been fully consolidated and reaches to the final stress. When it reaches to the final stress, then this is going to be sigma F dash. Then that is going to be sigma F dash. I hope you understood. So now once it reaches the final, then this UCC will behave like a NCC. Because when do you say NCC? So I reach the final. UCC means maximum is not known. But now I reach the final. What is the final? Sigma F dash, end of consolidation. And soil consolidated under which stress? Present stress or past stress? Now this is the present, this is the past. Present stress is more than the past. Then you can say this soil is going to be NCC. So I explained you in different ways. Now let me show everything in a figure, please. See, this is second time loading. This is second time loading. Now, I hope everybody will understand this one. Please have a look. Then NCC and UCC are same now? No, it's not NCC and see, when do you say NCC? When do you say NCC? NCC, see, look, I'll write down the difference over here. NCC, UCC, in both present greater than past. Here also present greater than past. Okay. Now soil consolidated under present, and this is during consolidation. This is during consolidation. For example, if you don't know the final stress, sir, if you don't know the final stress, you observe. What is the meaning of don't know the final stress? The soil will undergo consolidation or not? Yes, the soil will be during the consolidation. When the soil is during the consolidation, then I can write this one as UCC. But here again the present is going to be more than the past, but I said the soil is consolidated fully. When the soil is consolidated fully, then what is this over here? Sigma F dash. Now when it is sigma F dash, I said the soil consolidated. If during the consolidation, UCC, soil consolidated, NCC. Now, this is a NCC. So, at first, yes. Now, you see, you observe over here, first of all, I have applied a loading. Then the stress changes from sigma naught dash to sigma C dash. Stress changes from sigma naught dash to sigma c dash. And sigma c dash is more than the sigma naught dash. Soil is NCC. Soil is NCC. And then you remove the load. And then you remove the load. This is known as unloading. And again you apply the load. Already you have applied a load and the soil has been experienced sigma c dash. Yes or no? Now you are applying the reloading again, but now the present stress is less than the past, then we can call it as OCC. So up to this point, then the soil is going to behave like OCC. For example, let's take sigma naught dash as some 50 kilopascals. I can observe. First loading a building, a residential building. So due to this residential building, delta sigma dash is also going to be 50. Then what is sigma c dash? 50 plus 50, which is going to be 100 kilopascals or not? Yes. 50 plus 50 is going to be 100 kilopascals. Now, from this example, okay, from this example, I start, see, I'm explaining everything again over here. Please have a look. So what is sigma naught dash? 50. And due to first loading, this is the first loading R naught. Then the effective stress is going to be increases by how much? 50. Then what is the final stress over here? 100. So now from 50 to 100, what is the present? 100. Present 100. Past 50. Present is greater than past, which is going to be NCC. So now you see this zone. This zone is going to be what? This zone is going to be NCC. Okay, fine. So this zone is going to be NCC. I hope you understood up to this point. Now, unloading. When you unload, then delta sigma dash is going to be 0. Then delta sigma dash is going to be 0. Yes or no? And what is sigma dash now? Sigma naught dash only 50. But what is the earlier? Just before unloading, what is the pressure? 100. What is the present now? 50. Before unloading, 100. After unloading, 50. Present, 50. Past, 100. Present less than past or past greater than present. Now, can I say it as OCC or not? Now, you see, second loading. Second loading. Second loading is going to be, let's say, a 4-floor building. 4-floor building. In first floor, see, now I am constructing a 4-floor buildings. Okay. See, at first, what is the building? Residential building. So what is the pressure due to the residential building? 100. Now I remove the load. When I remove the load, again the soil will be which state here? 0. See, sigma naught dash 50. Okay. Now I am going to construct a 4-floor building. In the 4-floor building, see, please listen to this. In the 4-floor building, I have completed first floor. By the end of the first floor, delta sigma dash is 25. Then what is sigma dash? 50 plus 25, because sigma naught dash plus delta sigma dash R naught, which is going to be 75 kilopascals. Okay. Now listen to me carefully. Where is 75? This is 75 or not, because 50, 100, 75. But already now this is a present R naught. Already in the past. Now in the past, what is the stress that the soil has been experienced? 100. What is the present stress? 75. Present is less than the past, and the soil got consolidated under the past R naught. When the soil got under consolidated past, can I say this is the pre-consolidation pressure? Yes. Now in this state, soil is OCC. Soil is OCC. Now second floor. Second floor. Delta sigma dash again. By the end of the construction of second floor, I'll be explaining here itself. By the construction of second floor, delta sigma dash is equals to 50. Then sigma naught dash plus delta sigma dash, 50 plus 50, which is going to be 100. So now what is the stress now? Again 100. What is the present stress? 100. What is the pre-consolidated stress? 100. Up to this point, the soil is going to be OCC. Yes or no? Up to this point, soil is going to be OCC. And now, at this position, either it is not an OCC or NCC. So now at this position. Now let me go for the third floor. So fourth floor field opinion, right? For every floor, I am increasing a stress of 25. For every floor, I am increasing a stress of 25. Now, for the third floor, 3 floors, na 75. Now, what is the pressure that we are going to see? 50 plus 75. What is this? 125. You please observe now. What is the present stress acting on the soil? What is the present stress acting on the soil? 125. What is the past stress acting on the soil? What is the past stress acting on the soil? 100. Present 125. The 125 is going to be here. Past. What is the past? 100. The soil has already experienced 100, right? Now, up to 100, soil will behave like OCC. Now, from 100 to 125, soil starts to behave like a UCC. Because you don't know the end of construction. This is during the construction or not? Yes. Now you see the final floor, fourth floor, and each floor 25, 4 floors 100. Then what is the final stress? The final stress is going to be 50 plus 100, which is going to be 150. So present final is 150. Past, what is the past stress? 100. Again, it is going to be NCC or not? Now, I reached this 150. I got finally consolidated. Then I can say it as NCC. See, I explained you clearly over here what is happening due to first loading, due to second loading, due to unloading. I have represented this entire figure. So you please understand this one over here. Second loading is OCC up to, this is now this is going to be UCC. See, once I completed the building, then it is NCC. During the construction, UCC. End of the construction, NCC. During construction, UCC. End of construction, NCC. So that's about the explanation also. So with this, I mean, I hope you understood all the explanations. Just imagine and that's it. See, once I remove the structure, so end of construction is not end of consolidation, but end of construction means once the construction is going to be ended, at some point of time it is going to be reaches to its consolidation or not. But during the consolidation, do you think the consolidation will end? During the construction, do you think that consolidation will end? No. Once the structure complete, after some time, I don't know the time, it will undergo full consolidation. So now I have explained with more time and more example also. Yes. I hope you understood clearly. See, once I apply the loading, now you cannot look over this curve because this is loaded and unloaded, right? Right now, I explained two examples, residential building and 4th-floor building. So I demolished the residential building. Present, what is the building I am going to show you? Present, what is the building? Second loading or not? Now, let's take that graph outside. Let's take the second graph on outside, please. Okay. So sigma dash again, and this is going to be E dash. So let me take the second graph only outside. If I take the second graph only outside, now if you observe, now I hope now why I am drawing this one. Now you observe, see, this is second loading from sigma naught dash to sigma C dash. The soil behaves like a OCC because in this zone already soil has been experiencing this pressure. So as it is a second loading, now soil behaves like a OCC, and from here onward soil will behave like a NCC. Some of the students were asking, sir, why OCC has a convex upward, sir? Sir, why the OCC has convex upward? You please tell me, sir. Is it a compression curve or recompression curve, sir? Is it a compression or recompression? First time or second time? Second time. See, first you apply the load, soil will undergoes compression. Remove the load, it will regain a little bit. Now if you apply the load, do you think that compression in the second loading is same as the first loading? No. In the recompression, the compression is going to be very less. Now that less is going to be represented with this slope. Why it is a convex upward is its slope is going to be very less. Why it is concave downward is going to be, its slope is going to be more. So I told you yesterday, NCC undergoes more compression than the OCC. NCC undergoes more compression than the OCC. So this is the graph after the loading, means after the cyclic loading, you applied the load, you removed the load, you again applied the load, and up to this sigma C OCC, and then beyond sigma C up to the end, the soil behaves like a NCC. Now let me draw this same graph. Let me draw this same graph for log E scale, means log scale, okay? So now log based in sigma dash and E as a void ratio. So now in the case of the sigma dash, now if you observe the same graph, the same details, I'm providing the same graph. This is for cyclic loading, means loading and unloading. Now you see, in the case of the NCC, yesterday I have represented you, right? You please look over this one. You please look over this curve first curve. Yes. You please look out this curve. This is a convex downward or convex upward? This is convex downward. This is convex downward. Yes. So in the case of the convex downward, when I provide it in the log scale, it behaves like a straight line. It behaves like a straight line. Now, if you go for this one, as you know, this is going to be NCC and here it is going to be OCC. See, what I want you to observe over here is the NCC graph. Once you plot in a log plot, the convex downward will be act like a straight line, whereas OCC in the case of normal graph and in the case of the log graph, both are going to be having a small curve. See, this is a curve, this is not a straight line. Please understand, this is a curve, this is not a straight line. So now with this, I can write this is sigma naught dash this is sigma c dash, and here it is going to be sigma f dash. So now if you observe, this is the compression curve and this is the recompression curve where the soil behaves like OCC. I hope you understood what is the meaning of OCC and NCC. Now, the slope of this NCC is known as compression index. You know that because I have represented you. Please go through that once again. So this slope is going to be, what is the slope of this NCC? This is going to be CC, compression index now. And this slope is going to be CR. If you observe, the CR is very less than the CC, where CC is compression index. CR is recompression index. CR is going to be recompression index. So CC compression index, CR is going to be recompression index. And CR is equals to 1/5 to 1/10 of CC, because NCC undergoes more compression than the OCC. The curve also represents, the slope is very less, right? The more the slope, the more the value. CR and CC. So now you observe, we have completed this one. Now my question is, what is the total settlement? So total settlement over here is settlement in OCC plus settlement in NCC. Settlement in OCC plus settlement in NCC. You know that, right? So what is the settlement? The normal equation, you observe for normal equation, SF is equals to CC by 1 plus E naught into H into log base 10 sigma dash by sigma naught dash. Yes or no? You please remember that same equation, whatever this equation. CC by 1 plus E naught into H into log base 10 sigma dash by sigma naught dash. I told you clearly, this is initial void ratio, this is the initial thickness. Those are not going to be changes. Now, based upon this equation, what I am going to represent over here is the total or ultimate settlement. SF is equals to, first of all, OCC. This is OCC. In the OCC, who is initial? Sigma naught dash. Who is final? Sigma C dash. What is the slope here? Is it a CC or CR? CR. So in the case of OCC, then the slope is going to be like in this way. Observe, CR by 1 plus E naught into H into log base 10 You see, what is the final over here? For OCC, you tell me, up to what point OCC is going to behave? Sigma C dash from sigma naught dash. Sigma C dash by sigma naught dash plus what is the settlement of NCC? Now coming to the NCC. NCC is going to be start from sigma C dash to sigma F dash. Again, final by initial. Now what is the slope over here? CC by 1 plus E naught into H into log base 10 sigma F dash by sigma C dash. Sigma F dash by sigma C dash. See, what I have done is from this sigma naught dash to sigma C dash, the curve is going to be OCC, and the settlement in the OCC I have given you with what is the coefficient CR and what are the final stresses sigma C dash, initial stress as sigma naught dash. Whereas in the case of the NCC, what is the initial stress? Sigma C dash, final stress sigma F dash. So I explained how to derive this equation earlier. Now I'm not going to explain any derivation over here. So you just need to know this one. Yes, that's it. Note I can write over here as for OCC, curve will be convex downwards, convex upward in both normal and log plots. Sir, but void ratio E naught changes in NCC. Nana, it's this E naught means initial void ratio, which means before application of the load. Whatever the load that you not applied, E naught initial. I don't care what happens after the load. I will be caring what is the stresses changes. That's it. I'm not going to discuss about any change in the void ratio. I'll be taking the initial void ratio only, E naught. This is not minus ray, that is 1/5 to 2. Okay, fine. One-fifth to 1/10 of CC. So that's it about this loading, cyclic loading. See, the figures are there that you please observe. First loading, when you remove the load, now again you start the load, but soil has already gone this pressure. So OCC, and again from here NCC, and whatever the final figure is going to be OCC and NCC. Now after plotting this one, then we are going to get this in log scale. From the log scale, I can find out the final settlement. Sir, when to take 1/5 and when to take 1/10? Arey Baba, that's a range, Nana, that they will give you. Why you require that? Why OCC curve is not going to be changes, sir? So the slope of the OCC is going to be as slope is very less. The slope is going to be very, very less, which means 1/5 to 1/10 of the CC, right? As a slope is going to be very, very less. So now let's see a previous gate question regarding to this topic. Why I discuss this topic is so with respect to one question, you can understand that better. Yes. I hope you people are able to see this condition. See this one over here. Yes. See, this is a question that I have given you. Yeah. An undisturbed soil sample was taken. See, this is the question. This was a question in GATE 2016. When is the subject going to be completed? How many times you ask? How many times you ask? If you get bored, then get out of the class. Simply, I'm telling you. If you get bored, then get out of the class. I told you it will take time. And if I say, sir, tomorrow it is going to be completed, then you will feel happy. Yes. Instead of listening to the class, you are focusing on when the class is going to be ended. So when the break is going to be started. Now, look over this question. In this question, a undisturbed soil sample was taken in the middle of the clay layer. See, this is a clay layer. I hope you are able to look over this one clearly over here. So in the middle of the clay layer, let me represent this again. Yes. Yeah. So now, if you observe, I mentioned you here, this one has a 1 meter. And here this one has a 1 meter. And this is sand. Here it is going to be clay, where water table is located exactly at the interface. Now this is the ground level. So now, whatever the data they have given, the natural water content, see, I have mentioned you, a undisturbed sample was taken at the middle of the clay layer, 1.5 meter below the ground level. Middle of the clay layer means this is the layer. Yes or no? So a undisturbed sample has taken at the middle of the clay layer. So the total depth is going to be 1.5 meters. This is 0.5 and above is going to be 1 meter. And now laboratory test results was shown for the clay layer as the natural moisture content. So given what is the water content? The water content is going to be 25%. Pre-consolidation pressure, which means the pressure that the soil has been undergone in the past, is 60 kilopascals. What is the pressure that the soil has been undergone in the past? 60 kilopascals. And then compression index CC as 0.5 and recompression index as 0.05. See, they mentioned the CR. See, the CR is going to be 1/10 of CC now here. 1 by 10 of 0.5 is 0.05. And specific gravity of the clay as 2.7. Bulk unit weight of the sand is 17 kilonewton per meter cube. See, this is gamma, and below the water table, this is going to be gamma sand. Now, not only that, a compacted fill of 2.5 meter height with a unit weight of 20 is placed at the ground level. What is the meaning of compacted fill of 2.5 meter height with a unit weight of 20 is placed? What is the meaning of that? It is nothing but a surcharge, or not? Yes. So now, I am going to apply a surcharge. Surcharge. So what is the intensity of surcharge, please? 20 into 2.5. What is this 20 into 2.5? 50 kilopascals. So now this is the values. So I need to find out what is the finding. They're asking gamma W as 10 kilonewton per meter cube. The ultimate consolidation settlement, SF, they're asking a SF. So now the given details are there. You see, I have provided you the surcharge over here as Q. First of all, in order to determine the final settlement, you need to know initial overburden pressure and you need to know the settlement over here. You first find out the initial overburden pressure. For finding the initial overburden pressure, see, for the clay layer, you need to find out everything. So now, what is the final equation? Here is, first of all, you need to find out the unit weight of the soil. Yes. For finding the unit weight of the soil mass, what is the unit weight of the soil? Gamma sat G plus E naught by 1 plus E naught into gamma W. I have G with me, but do I have E? No. Now, from the Sevag, E into SR is equals to W into G. The clay is going to be fully saturated or not? This is E naught. The clay is going to be fully saturated, which means 1. E naught is equals to 0.25 into 2.7. 0.675. 0.675. Now substitute over here, please. Gamma sat is equals to G plus E 2.7 plus 0.675 by 1 plus 0.675 into 10. So what is this value? 675 by 1.675 into 10, which means 20.15 kilonewton per meter cube. So this is the gamma sat. Now, at the center of the clay layer, yes. Again, the same figure, whatever I have represented, see. So at the center of the clay layer, now at the center of clay, what is sigma naught dash? Gamma sand into 1 plus gamma dash of clay into 0.5. So what is the gamma sat into gamma of sand 17 and gamma sat 20.15 plus 20.15 minus 10 into 0.5. Then what is sigma naught dash? 20.15 minus 10 into 0.5. the value is going to be 20.15 minus 10 into 0.5 plus 17. This value is going to be how much? Now this value is going to be 22.075 kilopascal. You see, due to self-weight I have got the value, and now due to external load, what is the external load? Delta sigma dash R naught. So now what is delta sigma dash Q value? So what is the final here? Sigma naught dash plus delta sigma dash 22.075 plus 50, which is going to be 72.075 kilopascals. So now let's see why I have find out everything is, and now the point is this one, sigma C dash. What is the sigma C dash? Now if you remember the figures, if you see, I have given you the sigma naught dash. This is going to be the sigma C dash. Here it is going to be the sigma dash. What is sigma naught dash? 22.075. What is sigma C dash? Sigma C dash given as 60. And what is this value? 72.075. And you know that up to 60 kilopascals. See, already soil has experienced 60 kilopascals or not. Now I am telling the reason. What is mean by pre-consolidation pressure? The stress that the soil has been undergone consolidation previously. How much it is? 60. Yes. And then you remove. Now what is the initial orbital pressure? 22.075. Due to surcharge, how much stress is going to be there? 72. And while increasing, so from 22.075 to 60, the soil will behave like a OCC or not, because already that much pressure soil has experienced previously. So now if I draw a figure, the figure would be like up to this point OCC, and then from here NCC. This is OCC. Here it is going to be NCC. And this is nothing but pre-consolidation pressure. So now what is the final settlement is settlement due to OCC plus settlement due to NCC. I want you to understand all these things. I have included everything in this question. So this is the data. First you need to find out the initial overburden pressure. For finding the initial overburden pressure, I have finding the gamma sat and the initial void ratio. Now, so once I got these values, now what is the final settlement, please? The final settlement is equals to, for NCC, for OCC, CR by 1 plus E naught into thickness H into log base 10 sigma C dash by sigma naught dash plus NCC, CC by 1 plus E naught into H into log base 10 sigma dash by sigma C dash. So SF is equals to 0.05. I can take common. See what is the compressible thickness over here? The thickness of the compressible clay layer is going to be H value. What is H value over here? 1 meter. So 1 by 1 plus H by 1 plus E naught into CR into log base 10 sigma C dash by sigma naught dash plus CC into log base 10 sigma dash by sigma C dash. 1 by 1 plus 0.675 into So 1 CR 0.05 into log base 10 60 by 22 point, what is the value? 22.075 plus CC 0.5 into log base 10 72.075 by 60. So find out the SF value, please. Find out the SF value. I hope log 72.075 by 60 plus so which is going to be 0.03673 meters. They're asking in terms of mm, 36.733 mm. And did they mention anything in this question? No, just they're asking assuming unit weight of the water. So find the ultimate consolidation settlement in expressed. So as it did not give any range, the answer range would be range 36.52, 502, 36. The range is going to be whatever the value you get, you just keep it as this value. So the value, the range would be 36.52, 36.80. This would be the range. So you can keep the answer in any of these range values. See, what I want you is, you know everything. You know how to find out, but I just introduced one topic over here. See, haven't we done ultimate settlement yesterday? Yes, we have done that. But what is the only point that I have been explained over here is the sigma C dash. So for this sigma C dash, what is the meaning of sigma C dash? Is a pre-consolidation pressure. So up to that point, the soil behaves like a OCC, and beyond that point, the soil behaves like a NCC. I hope you understood the meaning over here. Yes. So you please have a look, please. If you have completed, then I go for the next topic. So please respond to my question. Yesterday or conducted test series now, it's question paper same for both ESC and GATE students. See, for paper is same for both GATE and ESC students, but the time is not going to be same, because for the ESE, you people have to conduct the test within 25 minutes. And for the gate, there's a 1 hour, because for ESE, that's a multiple choice questions. So, but next time the question paper for the both gate and ESE would be different. Next time for ESE, the question paper is going to be entirely different. For gate, the question paper is going to be entirely different. So do we neglect change in E? No, we don't neglect any change in E. Okay, fine. We have any logic here? See, whatever the logic only I explained over here. I made it this to bigger so that you can understand each and every point. I don't need to solve all these things. I can directly say, okay, they have given consolidation, means pre-consolidation pressure, which means up to pre-consolidation pressure, soil is OCC. Beyond pre-consolidation pressure, soil is going to be NCC. So what is the final pressure? I can find out the final pressure. So the final pressure is 72.075. So here OCC, CC, sorry, CR slope, NCC, CC is the slope. And for OCC final 60, initial 22. For NCC final 72, initial is going to be 60. So now that's about this. So now coming to the whiteboard of ours. So please respond, sir, is 50% good in a stress exam? 50% is good, but you have to be better. Arey Baba, if you have opt for ES and GATE, you don't need to worry. I will give you the question papers. Why you are worrying for everything? What the hell? Why you need to worry about for everything? Just remove some things from your mind. Focus on what is required. And if you're getting negative mark in this test, that doesn't mean that you are going to get the negative mark in the final examination also. Relieve yourself, okay? Just make sure you relieve yourself. Do not stress out. So nobody is going to be pull you or push you out. You are the one who is responsible for everything. You are responsible for your happiness and you are responsible for your sadness also. So first of all, make sure you are thinking in a clear way. So don't worry about that. That's a part and parcel in an examination. So for students, both GAT and SE get to have both examinations. So okay, fine. I'll make sure that. So the students who are enrolled GAT and ESE, I'll bring some solution for that. You don't need to worry about that. Mr. Limbasia, sir, in test and last question column dot, there was R by Z ratio greater than 1.5, but method through which I got is the Bose. See, for that question yesterday, I told you already, even though Westergaard is more accurate, but Bosnisk is more appropriate. So we use Bosnisk solution than the Westergaard's mostly. So don't worry about that. Now let's come to the class again. Sir, is GATE difficult or ESE? Nothing is difficult if you study. I'm telling you, nothing is difficult. So now coming to the next part over here. So if you look over the next part, now we are going to come into the part 2 in the consolidation chapter. The part 2 is Terzaghi's one-dimensional consolidation theory. Terzaghi's one-dimensional consolidation theory. So actually we call it as a Terzaghi's 1D theory. Now, in the case of the Terzaghi's one-dimensional consolidation theory, for every theory, the assumptions are very important. I'm telling you, especially for the ESC students, you please focus on these assumptions. From these assumptions, they can ask you which of the following assumptions are true according to Terzaghi. So they will give you the assumptions. They'll ask you which of the following are going to be true also. So please look over those. So first, number one, the basic is soil is homogeneous and isotropic. These are the basic assumptions. And soil is fully saturated and flow is laminar. So that Darcy's law is valid. So in the case of the Terzaghi, he assumed the flow is going to be laminar, so that the Darcy's law is also going to be valid, because you know Darcy assumed flow is laminar, and throughout consolidation, soil is fully saturated and expulsion of water occurs in vertical direction only. So what is the meaning of this one, sir? So throughout the soil is fully saturated, which means whatever the water, volume of water that goes out, means I told you during consolidation, degree of saturation should be 100% or not? Yes. And expulsion of water occurs in vertical direction only. See, I told you in the starting of the consolidation, soil is infinitely large in lateral direction. We discuss only longitudinal. Longitudinal means here as a vertical. And that is the reason why we call it as a one dimension. What is the meaning of one dimension? One dimension means only one direction, and that direction is going to be vertical direction only. And one more thing is permeability of soil should be constant. See, this is one more assumption. This Terzaghi has been taken. So, and this is suitable for primary consolidation only. Primary consultation only. Especially for the ESC students, I am telling you this chapter is very important, because whatever the theory, whatever the data I have been provided you, that's enough, but you have to apply your brains over here. Now, so based upon his assumptions, what he is going to be mentioned. I hope you remember the earlier equations and earlier details. So now let me take that earlier conditions again. I hope you remember this as ground level, and what is the soil? Sand. And what is the soil? Clay. And again this is going to be sand. This is the first example I have taken in this entire chapter. So throughout the chapter I'm using this example. So let's take the thickness of the clay layer as H. And you know the water table is going to be located up to this point. Yes or no? Yes. So now what I am going to mention you here is, look, you know that this is a sand layer. This is also a sand layer. At the center of the clay layer, you can find out the initial overburden pressure. Now recall our topics over here. So let me show you that once again. I think that's not opened. Yeah. Now please have a look about this. The same condition I have been explained over here, right? Yes. So I hope you can see these conditions over here. So the primary consolidation, I told you this theory, consolidation theory is suitable for primary consolidation only. So now, if you observe, so in the case of the primary consolidation, due to external load, initially I have given you the entire pressure will be taken by whom? Pore water pressure. Yes or no? And slowly water starts to dissipate. I told you, as the pore water dissipates, then the excess pressure is going to be decreased. Now here is, up to this point, did I discuss any time criteria? No. I have discussed what is the ultimate settlement, how to determine the ultimate settlement. But now in this what we are going to discuss is, see, for example, the ultimate settlement is going to be, where is that? Yeah. If you observe over here, when time t is equals to 0, settlement is 0. When time t equals to 0, settlement is greater than 0. Now the question is, if I give you time of 3 years, due to the constructed building, how much settlement is going to be happening? Or if I say for 50 mm settlement, how much time is going to be required? Which means I required time and I required the settlement. Earlier I discussed about the ultimate settlement, where ultimate settlement does not depends upon the time. Ultimate settlement does not depends on the time. Whereas if I give you for 3 years, if I get 10 mm settlement, for 10 years, how much settlement? Or for 10 mm settlement, it took 3 years. For 50 mm settlement, how many years it is going to be taken? So now let's see that conditions. So by using the same principles, whatever I have mentioned, now let's apply a surcharge of intensity Q. If I apply a surcharge of intensity Q, so now what happens to the pore water pressure? So at time T is equals to 0, So now at a time t is equals to 0. Please observe. See, when time t equals to 0, now I'll ask you one question. Let's imagine all of us are in one classroom. All of us are in one classroom. Okay, me, you, and some, let's say, whatever the students are there, let's say it's going to be one classroom. Or I'll explain you in a different way because you can imagine in this way much more better. Okay, fine. Let's say you went to a second show movie, not now, before the coronavirus, because there are no movie theaters now, but so before corona, before that means once upon a time when the days were normal. So I hope most of the people means obviously they used to go for the second show movies, right? Yes. So you went for a movie, second show movie, and so the movie, and you watched the movie and you came out of the movie. So by the time the second show will be ended, the people who came to the movie will be there. Yes or no? And no other persons would be there. For suppose you parked your car in a parking lot. For suppose you parked your car in a parking lot. You have parked your car in a parking lot. Now, my question is, if you want to come out of the parking lot, it takes some time for you, which means the time required for you to come out of the parking lot depends upon some factors. Can you please think about those factors? You don't need to write over here, means you don't need to send me the comment sections, but now observe the question clearly. You have parked your car in a parking lot and you want to come out of the parking lot, and the time required for you to come out of the parking is depends upon some factors. What are those factors? Can you please tell me? Sir, I don't have a car, only bike. Then you do one thing, Ray. You go with in the bike and you increase your speed to 200 kilometers per hour and you hit the divider, Ray. Faltu. Sir, I don't know. I don't know how to drive. You push the car, Ray. You don't. If you don't know how to drive, you push the car. You push the car simply. That's it. Sir, I have lorry only. Meerante unnolu, sir. Even I don't have a car, so don't worry about that. Type of road. I am asking you the time required for you to come out of the parking lot. Parking. Sir, which movie, sir? Hate story, sir. Hate story, Jism, Nasha, those type of movies, sir. You went to second show, sir? Some of our friend is saying, sir, if it is a corner seat, then we'll go quick, else long time, sir. I think you have a lot of experience in the corner seats, yes? And right now, the most thing that we miss is movies. Seriously, even I used to go to a lot of movies. Even when the times were of the during the class, also I mostly go for the second show. So once my classes used to end at 8 or 8:30 p.m., I used to go for second show movies. But now there is no movie theaters. And even if you want to watch in the OTT platform also, so Netflix or Amazon, they are not good movies right now because so there are no new movies. So have been watched all over the things and okay, fine. Ragini MMS. Okay, fine. So let's come to the session over here. Yeah. See, when you want to come out of the parking lot, mainly the time required for you depends upon, first of all, the number of cars in the parking lot, the number of cars in the parking lot. So you do please remember these points. Now I'm going to replicate these points in the soil also. So the number of cars in the parking lot, and number two, number of exits. See, if the number of cars are less, then the time required for you to come out of is going to be less. Yes. Number two, number of exits. If there are more exits, or if there are generally we go for one exit only, but if there are more exits, if your car is near to the exit, then you can come out easily. Yes or no? See, if the number of exits are more, then what happens? Then the distribution of cars to go one exit is and other exit is going to be there. So within less time you come out of the exit. So number of exits. And third one, velocity of the car. Velocity of the car. Yes or no? So velocity of the car means if the car in front of you will go with a higher velocity, then obviously you also will go with a higher velocity, right? Which means the velocity with which the car is going to be moves. So if the number of cars are there, obviously the traffic would be more inside of the parking lot. It will take some time. And if the width of the exit, is going to be more, then the car will go easily. So majorly, the time required for the car to go out depends upon number of cars, number of exits, and the third one is a velocity. So means a flow with which are the space, Nana. If the parking lot space is more, then obviously the car will move with a higher velocity, or means with the most velocity. If the space is very narrow, then the car has to move slowly. If the space is more, then the car will move free. So now, number of cars, number of exits, and the space of the parking lot, it all depends upon these three factors. Sir, why you are discussing about all these three factors over here, sir? Now let's see. Now I'm going to replicate. Now I'm going to replicate water in this car. So now you see, this is a clay. I hope now you please observe over here. This is a clay, and whatever the water particles, you can observe all these are going to be the water particles, just like the cars in a parking lot now. Just like the cars in a parking lot. So now you please observe carefully. Now this is one of your car. This is one of your car. So now, just like the parking lot, this is a clay consists of water molecules. Now I am replicating the car as a water molecule. Now I am replicating the car as a water. You know that. What is meant by consolidation? Expulsion of the pore water. And now that consolidation will take some time, which means it will take some time to come out of the soil mass. So now, as you know, it will take some time for you to come out of the parking lot. Now, the car depends upon number of water particles, number of cars are not. So the more the number of water particles, more the time it takes to come out. Number of cars. Number two, number of exits. I told you if the parking lot has more exits, then the water will come out easily in all the exits. Yes or no? So now you observe here, this is a drainage layer or not? Yes. So when it is going to be drainage layer, drained layer means the permeable layer. So now I can say whatever the water molecules are there here, they will exit through this, and you know the expulsion of water occurs in vertical direction only. So here, whatever the cars near to this exit, they will exit from here. Yes or no? And whatever the cars here, this exit, they will exit from here also. So at first, whatever the cars or whatever the water molecules near to the exit, they will expel out. Sir, what if my car is at center, sir? Sir, if your car is at center, then you can go either in this direction or you can go either in this direction, which means you are going to travel the same distance or not? Yes or no? Yes. And now, if there are two exits for you, and who is going to be the lot, means who is going to be the, which car is going to be the present with a long distance? If there are two exits for you, then the cars which is near to this exit will go first. The cars which is near to this exit will go first. Now, repeat and replicate with the water. There are water particles above sand, below sand. You know that sand is permeable layer. And when the water wants to go out, the water will go to the permeable layer or not. Whatever the water molecules near, see, these are some of the water molecules I am representing you here. These are some of the water molecules I am representing over here. So now, can I say this water molecule will escape easily? This water molecule will escape easily. So, and similarly, this will escape next. This will escape next. Then this will escape next, and this will also going to be escape next. So, who is the farthest water particle here? The farthest water particle is going to be at the center, because for the center, he can go above or he can go below, and what is the distance he is going to be travel is same. So now, after all this, what I want to say over here is yes. So now once again, please have a look. This is a sand which is going to be more permeable layer. So now, once I apply the surcharge, you know that if I insert a piezometer, once I apply the surcharge, then the water level in the piezometer will be rises above up to certain extent, and whatever this extra rise, this is known as a HE, and due to that excess pore water pressure gamma W into HE. So initially, when time t is equals to 0, now you tell me what happens. Initially, when time t is equals to 0, coming over here. Time t is equals to 0. What is the excess pore water pressure? See, you have seen different water particles, right? Yes or no? Wherever you insert the piezometer, you know that point number one, initially entire excess pressure will be taken by water and no dissipation when time t is equals to 0, which means whatever the pressure I applied, U bar is equals to Q, right? So at the top, whatever the water molecule is there, this is going to be U bar. And at center, at below, and at bottom, everywhere, the excess pore water pressure is going to be same. Everywhere, the excess pore water pressure is going to be same. So here U bar is equals to Q. Here also U bar is equals to Q. And in between, if you observe, everywhere this value is going to be Q. Sir, why everywhere the value is going to be Q, sir? You please tell me, sir. Because initially there is no dissipation of the pore water pressure. So initially U bar is equals to Q. I told the same point in the previous sessions also. Now there comes the most important discussion. What happens during the consolidation? During consolidation, which means when time t is equals to some t. So now what is meant by consolidation, right? What is meant by consolidation? The consolidation means expulsion of pore water. Yes or no? So now you please tell me which one will go escape first. These particles will escape first. The particles which are near to the exit, they will be escaping first. Yes or no? Yes. And the particles which are later, they will escape later. Yes. So here also, this is the next particle that will escape. Now, who is the farthest particle? Who is the farthest particle? Now, who is the farthest particle means you see, if you observe, this is going to be the farthest particle. Whatever the particle at the center, this is the farthest particle. Now, if he want to travel up or down, he is going to be travel the same distance. And whatever the distance traveled by the water particle, whatever the distance traveled by the water particle to the nearest exit is known as a drainage path. So what is this drainage path, sir? Now, where D is going to be drainage path. Drainage path means distance traveled by farthest water particle to exit. See, farthest water particle to exit. See, if this is a double drainage, now I'll be explaining over here. Distance traveled by the farthest water particle to the exit. You observe, if I say above and below there is a sand, and if this is a clay, then above sand, below sand, can I say it as a double drainage? Double drainage. Because above there is a drainage, below there is a drainage. Water will move above and water will move below. Then who is the farthest water particle? Center particle. Because what is the drainage path? Distance traveled by farthest means which is far away from the exit to the exit. So then the drainage path is going to be, the total thickness as H. So what is drainage path? H by 2. For the double drainage, the drainage path is going to be H by 2. Now, similarly, if this is the case, above sand, but below rock. Now, again, this is a clay. Now, can you please tell me, does the water will penetrate over here? Does the water will enter into the rock? No. Now, every water particle has to move from the bottom to the top only. Yes or no? Now, who is the farthest particle? See, if there is a single drainage, this is going to be the farthest particle. So, farthest particle, which means the distance traveled by the farthest particle to the exit. So this is going to be the drainage. Now, what is the drainage path over here? The entire drainage path is D is going to be H. So now this is going to be a single drainage. So in the case of the single drainage, D is equals to H. Sir, how come you fix whether it is a single drainage or double drainage, sir? Sir, if it is a permeable area above and below, then there is a double drainage. If there is no permeable layer, means if there is a permeable layer only on above, then there is a only single drainage. D is equals to H. Sir, if top and bottom there is a rock, sir, no dissipation at all, sir. So we don't need to discuss about all those things. So now let's come to the figure. Is it a single drainage or double drainage? Double drainage. Above sand, below sand. Then who is the farthest particle? Center. What is the distance it can travel above or below? D, drainage path. And what is this drainage path over here? H by 2. Now, you see, you observe carefully, please, over here. At a time t, this water particle who is near to the exit will be escaping first. Yes or no? When these water particles are going to be exits, then in this position, the excess pore water pressure is going to be 0. At the top, it is going to be 0. At the top, U bar is equals to 0. And at the bottom, because as it is a double drainage, right? As it is a double drainage, at the bottom also, U bar is equals to 0. At the bottom also, U bar is equals to 0. Sir, then what about at center, sir? Sir, when all the particles go, sir, then only center will go, sir, because center is the largest water particle or farthest water particle, sir. Then at the center, pressure is maximum. I'm telling you again clearly, as a time progress, whatever the particles, means you are a car. If your car is near to the exit, you will go out first. Then at that point, the excess pressure is 0. But what if your car is present exactly at the center? Then you cannot move that much easily. So you have maximum pressure. So at the center, the pressure is maximum. And now the variation looks like a parabolic variation with a maximum pressure at the center. U bar is equals to Q. And this variation is known as isochrone. This variation is known as isochrone. See, this is with respect to depth or not. You observe. See, this is with respect to depth. When Z is equals to 0, means at the top, pore water pressure is 0. When Z is equals to H by 2, at the center, what is the pore water pressure? Maximum. When Z is equals to H, means Z is equals to H, at the bottom, pore water pressure is going to be 0. So this line represents the isochrone. Isochrone means a line representing variation of whom? Excess pore water pressure with respect to depth Z. With respect to depth Z. So isochrone is the line representing variation of the excess pore water pressure with respect to depth Z. So this is the isochrone. So what is isochrone? The line representing the variation of excess pore water pressure with respect to depth. So at the top, pore water pressure is 0. Why? Those particles will go immediately. At the bottom, pore water pressure is going to be 0. Excess pore water pressure is 0. Why? At the bottom also, sand particles, means water particles, will move to the sand easily. But at center, it will take long time. Now, you tell me, end of consolidation, time t is equals to infinity. When time t is equals to infinity, what is the meaning of the end of consolidation? All the water particles means excess particles are going to be dissipated or not. Then the meaning of the end of the consolidation is at the top pore water pressure is 0, at the center pore water pressure is 0, at the bottom also pore water pressure is 0. See, I explained you these points in the case of the earlier also. I explained you these points in the case of the earlier also. Let me show that once again. If you see, I explained the same points. When time t0, excess pore water pressure is going to be Q, and time t, excess pore water pressure less than Q, at the end, excess pore water pressure is going to be 0. But this Terzaghi, what he has done is, not only he provided the variation with respect to time 0, time t, time equals to infinity, but also he provided the variation with respect to the depth. So now I hope you understood how this pore water pressure is going to be varies. Now, sir, in this case, how does the pore water pressure should be there, sir? Can you please tell me here? I told you when time t is equals to t, when time t is equals to t, for this the pore pressure distribution is going to be looks like parabolic variation with a maximum at the center. With a maximum at the center. Yes or no? So this total thickness is going to be H, the maximum at the center. And similarly, when time t is equals to t, here now you observe here this water particle will go here, then here u bar is equals to 0, but at this point this is the farthest particle or not? At the farthest particle the stress is going to be maximum. So now varies, but if you observe, this is going to be the maximum pressure. So here u bar is equals to Q and here u bar is equals to 0. When time t is equals to t. So which means during the consolidation. So here I explained you what is the drainage path and how the pore water pressure is going to be varies. So Terzaghi explains explained variation of excess pore water pressure with respect to depth Z and with respect to time t. With respect to depth Z and with respect to time also, you see time 0, time t, time is equals to infinity, and Z top, center, at bottom. So from this he has given an equation known as a one-dimensional equation, 1D equation by Terzaghi. So he has mentioned the equation is, I am not going to derive the equation, I'll be just writing down the equation. That equation is dou u bar by dou t. Dou u bar by dou t. What is mean by dou u bar by dou t? Variation of excess pore water pressure with respect to time, and dou square u bar by dou z square. You please observe what is this variation. The variation over here is parabolic variation or not? Yes or no? So the variation over here is going to be parabolic variation. So as it is a parabolic variation, so I am going to represent it in terms of the double derivative dou z square, and the relation between these two is going to be CV. So now dou u bar by dou t is equals to CV into dou square u bar by dou z square, where dou u bar by dou t is nothing but variation of excess pore water pressure with respect to time, variation of excess pore water pressure with respect to depth. This is one dimensional equation provided by Terzaghi, where CV is known as coefficient of consolidation. CV is known as coefficient of consolidation. So how to find out this CV? CV is equals to given as K by mv into gamma W. CV is given as K by mv into gamma W. This is very, very important, and especially in the case of the IES aspect, C for the IES, whatever the small topics also very, very important, where K is a permeability and mv is coefficient of compressibility. MV is coefficient of compressibility. So where CV is going to be coefficient of consolidation, and CV is equals to K into MV by gamma W. And now you see this CV, units of CV please. Units of CV. Units is equals to, what is the units of K? K centimeter per second or meter per second. And MV, what is mean by MV? MV quotient of volumetric compressibility, quotient of volumetric compressibility, not compressibility. So volumetric strain by stress. Strain has no units by stress. Stress means reverse. Kilonewton per meter square means meter square per kilonewton. And what about gamma W? Kilonewton per meter cube. Kilonewton per meter cube. So now let's substitute meter per second by meter square by kilonewton into kilonewton per meter cube. So now what is the units of CV please? Can you please tell me over here? So now this kilonewton will get cancelled, and 1 meter square will be over here. Then the units is going to be meter square per second or centimeter square per second. So the units of CV is meter square per second or centimeter square per second. So with this, I have included 4 coefficients: AV, quotient of compressibility; CC, quotient compression index; MV, quotient of volumetric compressibility; and CV, coefficient of consolidation. So now, if I solve this equation, then only we are going to get down the solutions, and that solutions are important for the gauge and IES. So we'll solve those solutions, means how to solve this equation and what are the solutions we are going to get. From this we are going to discuss after the break. So have a break. It's 11:30, and take the break up to 11:45, 15 minutes only, and we'll resume our session after 11:45. Okay. So let's get to the class now. Yes. So now by solving this one-dimensional equation, by solving one-dimensional equation, so whatever the solutions we are going to obtain are obtained. Number one, this is a time factor TV. Time factor TV. If you don't want to come on time, please don't ask to do that. See, I came late because I did a call to the team so as they can send the names of the yesterday's test names, means whoever the toppers. So don't give me a suggestion like if you don't want to come on time, please don't ask to do that. Okay. So those whoever is, if you dare to please keep your name, anonymous Mr. Anonymous attendee. So don't think you are in a right position to say to me what is right and what is wrong to me. Okay. And if you are the same enough, so those who have messaged me, can you please message me what is the number of marks that you have got yesterday's test? Have you attended the test? Have you attended the test? Just now you have sent me message, right? The person who messaged me, if you don't want to come on time, please don't ask me to do that. You please message. So Mr. Anonymous attendee, you please message your marks. How many marks you got yesterday? You please tell me your name. I can see your marks also. Now message Ray. Just because you have a comment section in your box, just because you have a comment section in box, you are able to question me, right? Okay, now solutions obtained are time factor TV. So first of all, the time factor. I told you, see, in the case of the ultimate settlement, we don't need to worry about the time, because ultimate means at the end of the consolidation. But in between, how the settlement is going to be happen. So question number one for you. Question number one for you. Think and means you don't need to answer over here, but you think. If I say the settlement happens as a 10 mm in 1 year, then what would be the settlement at the end of the second year? What would be the settlement at the end of the second year? So now, do you think at the end of the first year, if the settlement is going to be 10 mm, and by the end of the second year, it is going to be 20 mm? No. Initially, at first year, more amount of water used to expel out. When more amount of water is going to be goes, when more amount of water used to expel, see, initially I told you yesterday's shirt concept, right? If you remember the shirt, when you squeeze the shirt, initially more water used to expel out. So when more water expels, then more volume is going to be reduced. Yes or no? So in the initial time, the settlement happens more, and later on, as you squeeze the shirt, the amount of water coming out is going to be lesser and lesser and lesser. When the amount of water coming out is going to be lesser and lesser, the rate at which the settlement is going to be happen is going to be decreases. For example, in 1 year, if the soil undergoes a settlement of 10 mm, in the next year, from 1 to 2 years also, do you think it goes 10 mm? No, it will be happen less than 10 mm. So for example, at the end of 1 year, if the settlement is 10 mm, at the end of the 2 years, total 2 years, settlement is not going to be 20 mm. It will be less than 20 mm. Keep that in your mind. Initially, soil undergoes more settlement. Later on, the rate means per unit time. the rate at which settlement occurs will be decreases. So I cannot say directly, if soil settles 10 mm at 1 year, I cannot say directly at 2 years it is going to be 20 mm, at 4 years it is going to be 40 mm, at 10 years it is going to be 100 mm. It's not that simple. So now we need to get down the relation between the time and the settlement. How? This time factor is going to be helpful for us. So how to find out this time factor? Now, TV is equals to CV into T by D square. See, these are the solutions obtained by solving this one-dimensional equation. So don't worry about the derivation. You please understand the concept over here. So TV is equals to CV into T by D square, where T is time required for the consolidation. T is time required for the consolidation, and D you know that as drainage path, and you know D is equals to H for single drainage and D is equals to H by 2 for double drainage. So D is equals to H for single drainage and D is equals to H by 2 for double drainage. So now from this relation, you see, can I write from this relation, T is inversely proportional to on what factors the time is going to be depends. Now, on what factors the time is going to be dependent? On what factors the time is going to be dependent? Now you see, from this point, if I take this D to the other side, T is going to be directly proportional to D square or not? T directly proportional to D, which means D is nothing but drainage path. More the drainage path, more the time required. So you know the meaning of drainage path, right? What is a drainage path? Drainage path is the distance traveled by farthest. What is meant by farthest? Farthest means whoever water particle is longer, the distance is going to be long distance. So the distance traveled by the farthest to the exit is nothing but the drainage path. If the drainage path is going to be more, then the time is also going to be more, because from this I can write T directly proportional to D square. So the more the drainage path, the more the time. Now you see, in the case of the double drainage, the drainage path is going to be less. So the time required is going to be less. Now my question for you, in which condition consolidation occurs quickly? Single drainage condition or double drainage condition? Double drainage, because double drainage has a lesser drainage path. The lesser the drainage path, the more the time required. Sorry, the lesser the drainage path, the lesser the time required for the consolidation. Sir, compared to single drainage, how much time will be reduced to double drainage? Sir, wait for that. But as of now, consolidation time depends on the drainage path, and lesser the drainage path, lesser the time required. Okay, number one. And similarly, from this, can I write T is inversely proportional to CV? T is inversely proportional to CV, yes or no? T is going to be inversely proportional to CV. But what is CV? CV is going to be K by MV into gamma W. Can I write directly proportional to MV by K? MV by K, because CV is equals to K by MV. 1 by CV means MV by K. I'm taking gamma W as constant. Now, time is inversely proportional to K. Consolidation time is inversely proportional to permeability. Simple, Nana. The more the permeability, you know, if the permeability is more, then water will allow easily. Yes or no? When the permeability is more, then the water expels out easily. When the water expels out easily, consolidation happens quickly. The more the permeability, the less the time required for the consolidation. Similarly, coming to the compressibility, the more the compressibility, which means if the ability of the soil undergoes compression is more, then it takes more time because the compression is going to happen more and more and more. The time is also going to be more. So now the consolidation time depends upon mainly three factors. The consolidation time mainly depends upon three factors. Number one, drainage. Consolidation time, lesser the drainage, lesser the time. Second one, permeability, more the permeability, lesser the time. Third one, compressibility, more the compressibility, more the time. So I hope you understood from this relation. We can say that. So note, consolidation time depends on drainage condition, means single drainage or double drainage, permeability and compressibility of soil. And one more thing, you please look over here. What is the units of CV? Meter square per second or centimeter square per second. Now coming over here, let me represent CV as meter per second, meter square per second, meter square per second, and time second. Second will get cancelled.
Dear students, wait for some time. There is a power issue at faculty end.
So back, but we lost some details. So I hope everybody is here, but so we lost some time due to this power. So today almost 1 hour we lost due to the power cut and due to internet issues. But I want to show you something meanwhile before going to that. So see this one. Where is that? What was missed? Yes. So in yesterday's class, in yesterday, whoever have written Hyderabad is a metropolitan city, still frequent power cut. What to do, man? It's there. So in yesterday, I'm showing you an Excel sheet of the people who have attended. So if you see the first one who got highest mark in the gate is Miss Bhavani. So the rank is 1 for her. And next one, see one more thing, I have uploaded on a new one. Yes. So this is the gate yesterday's test series details. The people who have got highest mark over here is Miss Bhavani. So congratulations, Miss Bhavani. And if you are there in here, please come to a comment section. Yes. Next one is Tejas Ulhas Deshmukh, and he is also first ranker. So who got 28 marks, and Janga Sai Teja, Limba Sai, and Goganda Harinad, Shriman Cherupalli, and Chintan. So these are the first 6 people who got first ranks. And from the 7 people onwards, the second rank is not available. So we gave a second rank as a 7th rank over here. So, but the change for the first 6 one to the next one is very less. But you have given a tough fight over here. The first 6 people who got is a 28 marks, and the congratulations to all of you. I hope like you lose the 2 marks in one question only. So that as a numerical type, you must have done something better for that. So I hope you don't do those mistakes later, but you have done very good, which means out of the 30 marks, you got 28 marks. So I appreciate all of you people, and the remaining people, the Chintan, Aishwarya, so and Gedala Venkat Pavan. You see the difference between the top marks and the next marks are very less, 27, 26.7, and Rahul Jaishwal 26, Gaurav 26, Inder 26, and Muskan 26. Not only this, the people who have attended, so almost 350 plus students have attended for the GATE examination. So out of those, out of 30 marks, these people have got a very good marks. And apart from that, there are a lot of people who got a 25, 25.2, 24, and else. So this is for the GATE. And now, for the ESE, showing you ESE also. Yes. So I hope, yeah, I hope you people are seeing this ESE. In the ESE, Mr. Harshad. So out of 40 marks for the ESE, the 20 marks means 20 questions. So each question carries 2 marks. 40 marks out of 40 marks. The first rank is for the Mr. Harshad, who got 33 marks, and Miss Aditi 32 marks, Chandana 32 marks, and Mr. Chandan, Mr. Ash. So these are the 3 people who got 32 marks as rank 2, and you can see these ranks over here also. But so I'll appreciate you people, because within a less time for the IAS people, I think 25 minutes only. Within 25 minutes, you have attempted the 20 questions, and out of those 20 questions, you got 33 marks, 32 marks. I'm appreciating you people. So you please do the same things for the next test also. And from this chapter itself, you try to prepare more and more and more as you have a lot of resources. Classroom practice questions are there, previous GATE and previous IS are there. And if you have any other textbooks also, you please go through all those textbooks, means especially for the problems. So the upcoming chapters are going to be much more important. You please go with the same attention that you're paying for the previous classes, and I hope you very best. So the first ranker for the ESE is Mr. Harshad, and in the case of GATE, there are 6 rankers who got same marks. So I hope everybody is able to see those, and you can see your marks in your test series online login details also. That's all with the test yesterday, and I wish you very best for the next examinations also. I hope you are going to do the same thing for the next examinations. So in this case, if 6 to 7 people get same number, then how do they get ranked in GATE? Okay, yeah. So now let's come to the details. I have lost the previous session, but I saved some details. But those who are having the previous slide means the persons like we have discussed about the equation of the one-dimensional consolidation, right? So the one-dimensional equation, I lost that slide. If you have screenshot that slide, please share to my mail ID. Now, already it's 12:30. Let's start to the so solutions I was discussing you. By solving one-dimensional equation, the solutions we attained are, see, I'm writing those things. So directly time factor, because I have already explained this one, represented with TV. TV is equals to CV into T by D square, where T is nothing but time required for consolidation. See, today I'll be extending the class up to 1:30 because we lost almost 1 hour 15 minutes due to these power cuts and all those things. So time required for a consolidation, whereas D is nothing but drainage path, and where D is equals to H for single drainage, and H by 2 for double drainage. So the note point that I have given you here is consolidation time depends on drainage conditions, permeability, and compressibility of soil. Permeability and compressibility of the soil mass. This is one point. So I was discussing the second point now. You see, the units of the CV is going to be meter square per second, time second, and meter square by D, drainage path in meter square, which means TV is dimensionless parameter. Yeah, I don't know. Some of the people, I don't think. Do you think that I have to wait for you? See, one student said, "Sir, why should we wait for 1:30? We have other works to do. If we have power cut in our locality, will you wait?" Likewise, we can't for extra time. See, I do have some work. After 2 o'clock, I have to travel to Abitsa and I have one more class to record the sessions. And I'm having a class up to 8:30. From 2 to 8:30, again, I have a class. I'm taking a class for you from 9 to 1. My given session is from 9 to 1 only. But every day I take 1 to 1:30 as a doubt clearing session. I don't need to take that doubt clearing session for you. If I think the same way, whatever the person who has asked me, "Sir, why I have to wait?" Then why should I have to discuss and why should I have to waste my time as a half an hour or 40 minutes for you to discuss? I'm clearing everything in the classroom. You can go through the live video sessions and you can repeat the live video session so that you can understand. Then why I have to repeat the same concepts again and again? Don't think I am a worker of your home or someone else, okay? See, if you want to leave, you can leave. Okay, fine. The people who wants to leave, they can leave, and you can go for the tomorrow recorded video would be there. So if you want to leave, you can leave. I'm going to continue that, and I hope most of the people will present and they go with my idea. So I hope so. I don't know, like some people ask foolish questions and some people are treating like a faculty. Okay, so as I am just a 5 to 6 years senior than you. So if the person is going to be some 40 or 50-year-old, are you going to do the same thing? Respect, yeah. I don't want your damn respect for me. Give respect to the class, to the subject. I thought of disable the chat during the discussion, but it's not happened. Means it's not provided over here. Otherwise, I would have asked of that. Okay, fine. I don't want to waste some more time for such type of people. Now, coming to the second degree of consolidation, represented with capital U. You see, this is not a small u, this is a capital U. Degree of consolidation represented with a U in terms of percentage. Sir, the second solution is degree of consolidation. What is this degree of consolidation, sir? Sir, degree, extent of measure, consolidation, how much consolidation has been happened. So the degree of consolidation means a percentage of consolidation, percentage of the consolidation occurred. Percentage of consolidation done. Degree of consolidation means how much consolidation happened. Now, my question for you is, you know that degree of consolidation means expulsion of pore water. Yes. Now, when time t is equals to 0, I'm asking you, when time t is equals to 0. So now you know that what is the degree of consolidation when time t is equals to 0? What is the degree of consolidation? U is equals to 0, because when time 0, no dissipation. When there is no dissipation, no consolidation. So U is equals to 0%. And when time t is equals to 0, what is the settlement? Settlement is also going to be 0. What is meant by settlement here? Delta H. And what about the excess pore water pressure? See, I am explaining you with this condition. Now, when time t is equals to 0, I am going to write everything over here. when time t is equals to 0, what is excess pore water pressure? Initially, the entire excess pore water pressure is going to be taken by water. So U bar is equals to Q. And what about the initial settlement? Settlement is equals to 0. Then what about the degree of consolidation? 0%. I hope you understood this one. Yes, when time t equals to 0. Similarly, when time t is equals to infinity, what is the meaning of time t is equals to infinity? At the end of the consolidation, right? What is the excess pore water pressure? 0. And what is the settlement over here? Final settlement. S becomes SF. Yes or no? So now at the end of the consolidation, entire excess pressure dissipates, then the degree of consolidation is going to be 100%. So degree of consolidation means percentage of consolidation. When time 0, no consolidation. When time t is equals to infinity, entire consolidation. Now I'll give you other definition as U is the percentage of excess pressure dissipated. The percentage of excess pressure dissipated. Sir, what is the meaning of this one, sir? For example, I'll give you one question. Listen to the question and understand. The symbol is U. This is U, Nana, capital U. Please make sure this is capital U, U, capital U. U is the degree of a consolidation. Now, how to find out this degree of consolidation, sir? This U in terms of percentage is equals to UI bar minus U bar by UI bar into 100. What is this UI bar, sir? UI bar means, I means initial, bar means excess pore water pressure. Initial excess pore water pressure. Initial excess pore water pressure. What is U bar, sir? Excess pore water pressure at time t. At time t. So now let me give a small example for that. A pressure of 50 kilopascals is applied on soil uniformly. The meaning of pressure is applied uniformly means that's going to be act like a surcharge. Yet during consolidation, at a certain time, excess pressure or excess pore water pressure is measured as 20 kilopascals. Then the degree of consolidation is. Then the degree of consolidation is dash. So what is the degree of consolidation over here? So now if you see the solution, I want to find out the degree of consolidation. You know that whatever the pressure I applied is nothing but a Q, 50 kilopascals. Yes. Then what is UI bar? UI bar means, you see, when I apply 50, entirely the 50 is going to be taken by whom? Saturated clay, and which is nothing but water or not, which means whatever the initial excess pore water pressure is nothing but 50 kilopascals. So now, what is the definition of the U? Is the percentage of excess pressure dissipated. Now, at some time t, what is U bar? I have mentioned the 20 kilopascals, which means at some time t, excess pressure. Arey Baba, initially what is excess pressure? 50. After some time t, how much? 20. Then how much dissipated? How much dissipated? From 50 to 20, how much reduced? 30. And what is the percentage meaning? Out of total. Yes. So what is the percentage dissipated? 30 kilopascals is dissipated out of total as 50 kilopascals. So then what is the degree of consolidation is? U is nothing but UI bar minus U bar by UI bar into 100, which means 50 minus 20 by 50 into 100. What is this value? 60%, which means 60% of excess pore water pressure is dissipated. Just you can imagine, right? 50 is applied, 20 is at some time t, and how much decrease? 30. Out of 50, 30 is nothing but 60% or not. So this is how you need to find out the degree of consolidation. And there is one more formula for this one. There is one more formula. This is A. And there is one more formula to determine the degree of consolidation. The B is the degree of consolidation can also written as S by SF into 100. S by SF into 100, where SF is ultimate or maximum settlement and S is settlement at any time t. You see, you observe over here, if you observe here, when time 0, what is settlement? 0. Yes or no? Now come over here. When time t 0, settlement is 0. When settlement is 0, what is degree of consolidation? 0. When time t is equals to infinity, what is settlement? What is settlement? SF. When the settlement S is equals to SF, SF by SF, 100. Then what is the degree of consolidation? 100. So either you can use this relation. If they give you the excess pore water pressures, you can go for this relation. If they give settlements, they can give, means you can go for this relation also. So now, so this is going to be U S by SF into 100. So now I have two solutions. One is time factor and other one is the degree of consolidation. You please listen clearly. This time factor represents the time. This time factor represents the time. And degree of consolidation represents the settlement. Time factor, time, degree of consolidation, settlement. Yes or no? Yes. Now, I need to find out the relation between time and settlement. Settlement is seen in the degree of consolidation. So if you know the degree of consolidation, you can find out how much a settlement is going to be happen. And if you know the time factor, you know the time. Now I need to find out a relation between time and settlement. Time is in TV, settlement is in U. Now what we are going to get is a relation between time factor and degree of consolidation. Relation between time factor and degree of consolidation. So now if you see, when U less than or equals to 60%, the time factor TV is equals to pi by 4 U square. TV is equals to pi by 4 U square. See, when U is going to be less than or equals to 60%, you have to find out TV is equals to pi by 4 U square. This is the relation between the time factor and the degree of consolidation. So if I say degree of consolidation is going to be 50%, and mind it, while you are substituting, this U should be in terms of decimals. This U should be in terms of decimals. For example, if I say degree of consolidation is going to be 50%, then what is the TV, sir? Then what is the time factor, sir? Time factor is equals to pi by 4 into, as U less than or equals to 60% or not? Yes. U as 0.5, not 50%. Similarly, when U greater than 60%, then TV is equals to 1.781 minus 0.933 log base 10, 100 minus, now here U is in terms of percentage. If you observe, now here U is in terms of the percentages. So when U less than 60%, when U less than or equals to 60%, TV is equals to pi by 4 U square. When U greater than 60%, TV is equals to 1.781 minus 0.933 log base 10, 100 minus U in terms of percentages. So this is the equations that you need to remember, the relation between the time factor and degree of consolidation. Now, note point, yet U is equals to 60%. Then what is TV? Less than or equals to 60, right? Pi by 4 into 0.6 square. You are going to get as a 0.286. I'll be letting to know what is the usage of this one later. I'll be letting to know what is the usage of this 0.286. And one more point is, theoretically, for complete consolidation, time is infinite. Theoretical, for complete consolidation, the time is going to be infinite. That is what I am saying over here. Time is infinite for complete consolidation. But for practical problems, if degree of consolidation is more than or equals to 90%, we can take soil is fully consolidated. Soil is fully consolidated. See, this is the note point. If I say consolidation time is theoretically infinite, but for practical solutions or for practical problems, we say that if the degree of consolidation is going to be more than or equals to 90%, then we can say that the soil is consolidated. So this is the point that you have to find out. This was one of the previous IS question also. So which one of the following statements is true? They have given some statements and they said that theoretically consolidation time is infinite. Yes. So this is the relation between the time factor and the degree of consolidation. Now, let's see some of the conditions. What is the purpose of this one everywhere? Okay. Now, you see here, again, note, TV depends upon, you look over here. What is this TV? TV is equals to CV into T by D square. Yes. So CV depends on soil. Yes or no? Why? What is CV? CV is equals to K by MV into gamma W. K means permeability. MV means compressibility of the soil. So CV depends upon the soil. For the same soil, CV is going to be constant. Same soil, CV is going to be constant. And D depends on drainage conditions. Whereas TV depends on degree of consolidation. TV depends on degree of consolidation. Okay. So now let's take some conditions. Condition number 1. By keeping all other variables constant, if drainage condition is changed from single drainage to double drainage. Single drainage to double drainage. See, by keeping all other variables constant, what is the meaning of all other variables? CV and TV, everything. By keeping all other variables constant, if the drainage condition is changed from single drainage to double drainage, now I want the ratio of time required in single drainage to ratio of means a double drainage is how much. So now see the solution for this. You know that TV is equals to CV into T by D square. Now, have I changed any soil mass? No, which means CV is going to be constant. Have I discussed about any degree of consolidation? TV is going to be constant. What I changed is drainage condition only, right? Then T directly proportional to D square. T directly proportional to D square, which means T of single drainage to T of double drainage is equals to, you know that for single drainage, what is D value? H by 2 whole square. H by 2 whole square. You know that for single drainage, D is equals to H. For double drainage, see DD means double drainage, D is equals to H by 2. So then this is going to be 4, which means the time required for single drainage is equals to 4 times of the time required for the double drainage, or the time required for double drainage is equals to 1/4 of the time required for the single drainage. See, this is a very, very important in the case of IES. There are n number of questions asked in the IES based upon this condition. So you know that I told you earlier, if the drainage path is less, time is less. Now, if I reduce the single drainage to double drainage, then the time is going to be reduced by 1/4. And if you increase the drainage from double drainage to, if you change double drainage to single drainage, then the time increases by 4 times. Simple point. If drainage changes from double to single, time increases by 4 times. If drainage changes from single to double, time decreases by 4 times. If this is the case, now I hope people are able to see this. Yes. So earlier I have discussed one of the previous gate question, right? Now, yes, you please look over this. This was a previous IES question or ESC question. So I want you to look over here. Yeah. So now, if you observe here, a clay layer 5 meters thick is in a clay 300 days to attain 50% consolidation. To attain 50% consolidation, it took how many days? clay layer of 5 meters thick. So what is the thickness of 5 meters? So it took how many days? 300 days for 50% consolidation. If the same clay layer is underlain by hard rock, what is the meaning of see a clay layer 5 meters thick with the condition of double drainage? It is going to be 300 days. So if the same clay layer is underlain by hard rock, what is the meaning of hard rock? So initially, this is a clay layer above and below. Now, if the clay layer is going to be underlain by a hard rock, then what is the meaning of this one? This is a double drainage and this is going to be the single drainage for the same consolidation. For same soil CV constant, yes, and for same degree of consolidation TV constant. You know that T directly proportional to T square. So T of single drainage is equals to 4 times of T of double drainage. For 30 days, you observe over here. For double drainage, the time is going to be 300 days. Then what about the single drainage? 4 into 300, answer is going to be 1200 days. I can write it directly. By seeing the question itself, I can say the answer. Okay, double drainage 300. Then if the same clay is underlain by hard rock, then it is going to be single drainage. Single drainage time is 4 times more than the double drainage. 4 into 300, answer is going to be 1200 days. I hope you understood this. Now, meanwhile, I'll be solving one more thing over here. You please look over here. This is also previous ESC question. The E versus P. This is E versus P means a sigma dash and E. It is not log. So I can see, you can see this curve. This curve is nothing but the compressible curve. Quotient of compressibility AV. You know that AV is nothing but delta E by delta sigma dash. What is delta E? 0.85 minus 0.8 by delta sigma dash. 400 minus 200. 0.05 by 200, which is going to be 2.5 into 10 to the power of minus 4. This is AV value. So answer is going to be C. Answer is C. This is one of the previous IS question only. And yes, one more question. You please look over here. The natural void ratio of a saturated strata. The natural void ratio of a saturated clay strata 3 meters thick has a void ratio 0.9. So initial thickness is 3 meters. Void ratio is 0.9. The final void ratio at the end of the consolidation given is 0.71. Then the total consolidation settlement delta H is equals to. See, I don't have CC and all those things. What I do is I simply go with the one relation. You know that delta H by H is equals to delta E by 1 plus E naught. So I am asking you delta H. So now delta H by H is equals to delta E naught minus EF by 1 plus E naught. Delta H by H as 3 meters is equals to 0.9 minus 0.71 by 1 plus 0.9. You see 0.19 by 1.9, right? 0.9 minus 0.71 means 0.19. 0.19 by 1.9 means 0.1. So delta H is equals to 0.1 into 3, which is going to be 0.3 meters. Answer is going to be 30 centimeters. Answer A. These are simple questions. Direct application of this relation delta H by H is equals to delta E by 1 plus E naught. From this relation only I have find out the CC and all those things. So wherever there is a possibility, use this relation delta H by H is equals to delta E by 1 plus E naught. So now that's about these conditions. Now, you see, this is also one more previous IS question. So why I want to look over here is just whatever the concepts that I have been explained. Excess pore pressure distribution within the thickness of soil sample tested in odometer. Means odometer means a consolidometer that will be discussed at the end. Tomorrow we'll be discussing that. Okay, fine. So, but let's go for the next condition. Yes. So this is condition number 1. What I want to say here is, yesterday the paper said by you was difficult or hard. No, it's not difficult or hard. It is medium. Yes. Now, coming to the condition number 2. This is the main condition we require. So now, let's see. We are staying in one building, right? And now, definitely this building has some period of time. Means, let's say, suppose you are staying in a building of a 10-year-old, which means from the past 10 years, the building you are living on is applying a load on the soil. And due to that load, definitely soil would have undergone some settlement. Yes or no? Now, I need to get down the relation between the time and settlement. A building constructed on compressible clay layer undergoes settlement with respect to time. With respect to time. A building constructed on compressible clay layer undergoes settlement with respect to time. So now my question is, relation between time and settlement. Relation between time and settlement. So now you see what is the relation between the time and the settlement over here. So solution again. TV is equals to CV into T by D square. My dear question, listen carefully. I have these many factors and you know that the CV depends upon the soil. Question number 1. Once I construct the structure on a given soil, can you change the type of soil? Can you change the type of soil? Now see, before constructing the soil was clay. After construction, do you think the clay is going to behave like a sand? No. Once you construct the structure, the soil type is same, which means same soil, CV is constant. Same soil, CV is constant. Now, once I construct a structure, can you change the drainage condition? No. Can you change the drainage condition? No. Same drainage condition, D is constant. Sir, did they mention that drainage condition is going to be constant or not, sir? Sir, you please apply your brain, sir, you can understand. Are Baba, once you construct a structure, can you change the hard strata or can you change the soil type? No. Once I construct a building, soil will not change and the drainage conditions will not change, which means CV and D both are going to be constant. When CV and D both are going to be constant, CV is constant, D is constant, then TV is directly proportional to T. TV is going to be directly proportional to T. So now, if you see TV2 by TV1 is equals to T2 by T1. And you know that TV depends on degree of consolidation. Sir, why the degree of consolidation is not constant, sir? Sir, with respect to time, kya hota, sir? You see, I said a layer undergoes settlement with respect to time. With respect to time, as settlement undergoes, degree of consolidation increases. Now, with this, how I'm going to find out over here. So now let's see. Let me take with one example. With the example, I will be make you understand more clear. Example. Listen to this example clearly. A building constructed on clay settles by 50 mm in 3 years. If the ultimate settlement of clay is 150 mm, or let's say if the ultimate settlement of clay is going to be 200 mm. See, what is the meaning of this one? See, I constructed a structure on a clay soil, and I got to know by the end of the 3 years, the settlement was 50 mm. Now, if the ultimate settlement of the clay is 200 mm, if the ultimate settlement of the clay means maximum settlement, you know how to find out the ultimate settlement SF? Then the time required to settle 100 mm is. So this is the question I am giving you. Now, why I left this space is for making you understand. Yes. Now see the solution. Have I changed the soil? Clay is same. Have I discussed any drainage condition? No, drainage conditions are same. So now you know that TV is directly proportional to T. TV is directly proportional to T. Yes. Given the details are for time T1 3 years. What is S1? 50 mm. Now for S2 100 mm, what would be the time T2? What would be the time T2? And given SF is equals to how much? 200 mm. So now you know that TV directly proportional to T. Yes. And TV depends on whom? Degree of consolidation. So now I want to find out the time. Yes or no? As you know the time, you know that I want to find out the time. What is the time? T2 by T1 is equals to TV2 by TV1. T2 by T1 is equals to TV2 by TV1. Yes or no? And now I need to find out TV2. Please listen to the question once. Once I complete, then only you can understand completely. Now, you know that. You know T1. What is T1, please? 3 years. I know T1. And I need to find out TV2 and TV1 in order to find out T2. But TV depends upon whom? U. And TV1 means U1. So now let's find out U1, please. What is U1? S1 by SF into 100. So 50 by 200 into 100, which is going to be 25%. And what is U2? S2 by SF into 100, which means 100 by 200 into 100. What is this value? 50%. Sir, why you have taken this much time for this one, sir? Now you see what is going to be happen. What's going to be happen over here is, if you observe, as U1 and U2, U1 is 25%, U2 is going to be 50%. Both are less than 60%. So U1 comma U2 both are less than 60%. So now my condition is, let's go back to here. As you know, TV depends upon the U in terms of percentage, and you know that when U less than or equals to 60%, TV is equals to pi by 4 U square. When U greater than 60%, TV is going to be 1.781 minus this value. So now let's come to the condition. I did not get the relation between time and settlement yet. So the condition A over here. If U1 comma U2 both are less than or equals to 60%. If U1 comma U2 both are less than or equals to 60%, then you know that TV1 is equals to pi by 4 U1 square, TV2 is equals to pi by 4 U2 square. Yes or no? So when TV1 and TV2 both are going to be the same, then can I write, you know that when both are going to be same, then can I write TV is equals to pi by 4 U square? Yes, because as U less than or equals to 60%, TV is equals to pi by 4 U square. Can I write TV is directly proportional to U square? Yes. And now, as you know, U is nothing but S by SF into 100%. See, SF is going to be constant because final settlement, and U directly proportional to S. Yes. So now by taking all these relations, and you know this relation, right? TV directly proportional to T. So now from, let's take this as equation number 1. Let's take equation number 2. Let's take equation number 3. From 1, 2, and 3, TV is directly proportional to T from 1, directly proportional to U square, directly proportional to S square. Because if you observe here, as U directly proportional to S, U square means, then definitely it is going to be directly proportional to S square. Then what is the relation between time and settlement? The relation between time and settlement from this one, can I write it as T directly proportional to S square? T directly proportional to S square. So very important. Now finally, I got the relation between the time and the settlement. So what I have done simply over here is, if U1 comma U2 are going to be less than 60%, then TV1 and TV2 formula is same. So I can write TV directly proportional to U square and U directly proportional to S. From this I can use this relation. So that is the reason why I framed this example, and I made sure how to find out U1, how to find out U2. From this example, I got to know U1 and U2 are less than or equals to 60%. Now, can I use the relation T directly proportional to S square? Yes, I can use this relation. Don't think this relation is going to be suitable for everything. This is suitable only for when U1 comma U2 less than or equals to 60%. So now from this relation, can I find, I want for T2. T2 by T1 is equals to S2 by S1 whole square. Then what is T2? S2 is given as 100 by 50 whole square into T1 as 3 years. So what is this value? Please tell me. 50, 100 by 50, 2 square, 4. So which is going to be 12 years. Observe clearly. First 50 mm requires only 3 years. Yes or no? Now what is S2? 100 mm. From the next from 50 mm to 100 mm, what is increase? 50 mm. For the next 50 mm, it took a time from 3 years to 12 years. So don't think that time and settlement varies linearly, and they are going to be varies, you see, parabolically. And this relation is applicable when time directly proportional to s square. When t directly proportional to s square. So now, sir, you have given that if u1 comma u2 less than or equals to 60%, then I'll ask you one more question in this B. Time required for 150 mm settlement. Time required for 150 mm settlement. Now, what is S3? 150 mm. And what is T3? We required. And you know that S1 is 50 mm. And T1 is how many years? 3 years. See, you can take S2 also. That's not a issue. Now, you see, already you find out that S1 is going to be, U1 is going to be 25%. Because you know, na, what is U1? 25%. So now I want to find out the time required for settlement 150 mm. What is the maximum settlement I have? The maximum settlement is going to be 200 mm. So now I want to find out what is the time for 150 mm. So now find out the U3, please. S3 by SF into 100. 150 by SF, 200 into 100. Now this is 75%. So now in this case, you please observe, this is less than 60% and this is more than 60%. So can you please tell me, can I apply the condition over here? Can I apply the condition over here? So everybody, you tell me, here U is less than 60%, U2 is more than 60%, then can I use this relation? No, you cannot use that relation. Then what happens, sir? B. If U1 less than 60%, U2 greater than 60%, then TV1 is equals to pi by 4 U1 square, TV2 is equals to 1.783 minus 0.933 log base 10 100 minus U in terms of percentage. That's it. There is no other option. You cannot use this relation. You cannot use T directly proportional to S square everywhere. You have to use when U1 comma U2 less than or equals to 60%. See, in this question, I made sure U1 and U2 less than 60%. Now, you know that TV directly proportional to T, T2 by T1 is equals to TV2 by TV1. No option for you. You cannot use this logic. You have to go through the basic. You need to find out TV1, you need to find out TV2, and you need to find out the T2 value. Now let's check over here also. Then from this, TV1 is equals to pi by 4 into, you observe what I am doing over here, 0.25 square, which means I am using a decimal over here. I am using a decimal. 0.25 square, which is going to be 0.049. And what about TV3? 1.781 minus 0.933 log base 10, 100 minus what is U3? 75%. See, this is going to be percent because 100 minus in terms of percentage. 100 minus 75 into 0.933, 1.781 minus answer. So this value is going to be 0.476. So now I know these values. So TV directly proportional to T and T3 by T1 is equals to TV3 by TV1. So from this, what is T3? TV3 is 0.476 by TV1 0.049 and T1 has 3 years. So which is going to be 29.18 years. I hope you understood with the example. So whenever a building is going to be constructed, you see, let me repeat this condition again. Whenever a building is going to be constructed, now, whenever a construction is going, building is going to be constructed, you know that with respect to time, the building will undergo settlement. Now, does that settlement is going to be linear with respect to time? No, it depends upon the degree of consolidation. So how to find out that? So now, as once I construct the building, the CV soil is going to be constant and D drainage path is also going to be constant. So TV directly proportional to T. Now, as a TV depends upon the degree of consolidation, if U1 comma U2 are going to be less than 60%, if U1 comma U2 are going to be less than 60%, then TV directly proportional to U square, then you can use this relation directly, T directly proportional to S square. And if U1 comma U2, one is less than 60 and more than 60, then you need to find out TV1, you need to find out TV2. So what is TV over here? TV. Now, this is an example that I mentioned you over here. So a building constructed on clay settles by 50 mm in 3 years. If the ultimate settlement of the clay is 200 mm, the time required to settle 100 mm is. So for 100 mm, for 50 mm, what is U1? 25%. For 100 mm, what is U2? 50%. And you know U1 and U2 less than or equals to 60%. Then I can use directly this relation T directly proportional to S square. But in this example, what is the time required for 150 mm settlement? Which means S3 150. Then what is U3? 75. So one is going to be less than 60, other one is more than 60. Can we apply this relation? Can we apply T directly proportional to S square? No. Then you have to go for the basic TV and TV3. So you need to find out that TV1 by using this equation, TV2 by using this equation. Then you substitute here, you can find out the values. So please go through that once again. How TV depends upon you, sir. See, that was the relations. These are the empirical relations. The time factor. The time depends upon the consolidation. Time, TV, time, and U consolidation. In the case of IAS examination, they will be providing you the values, so you don't need to worry about that. With this, we'll be complete this session. Sir, 29 years is total years. Yes, 29 is total years, Nana. 29 means total years. This is 29 as a total years. Sir, it is time from 0 to 150 or 50 to 150. This is 0 to 150. If both are greater than 60%, then you have to go with the same procedure. Then TV1 and TV2 use the same equations. And yes, I am enough for the means. See, in the examination for IES, there is no provision of log values. If they give the log questions, then they will be providing the log values also. Don't worry about that. See the TV time. The TV is a factor which represents the time. That's it. There is no physical meaning for the TV. Sir, whether lockdown ends 31st, institute will run? No, actually, if the lockdown ends also, until or unless the education ministry says to open the education institutes, up to that point, institutions are not going to be open. Sir, in yesterday IES exam, I got 31 marks. Is it okay or bad, sir? That is a very good sign, Mr. Sai Krishna Aditya. You have done very good. Yeah, so with this, I'll be, see, I just introduced this topic today, and tomorrow we are going to see the modifications of this topic and how, see, this topic is very, 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 very important in the case of GATE. I'm telling you, there are a lot of questions asked in GATE based upon this topic. I'll be discussing the previous GATE questions, IES questions, and classroom practice questions based upon this topic tomorrow. Meanwhile, if you can solve those questions, you please try to solve. You please try to solve. Those who wants to go for the classroom practice questions, you go for the classroom practice questions. You try to solve it on your own because you know the topic. Now tomorrow I'm going to discuss some logics, how to apply those. So as of now, I'm going to take a leave because so this is already it's going to be more than 1:30. So I'll be discussing the remaining tomorrow. Yes. So as of now, today I'm ending the session and see, I'm asking you, see, I lost one slide. I lost one slide where I discussed that one-dimensional consolidation equation is there, right? Dou u bar by dou t is equals to CV into dou square u bar by dou z square. The people who are having that slide, please send me that slide to my mail so that I can attach as soon as possible. Please that. Sir, it's hard to hear that you are going to take a class again from 2 o'clock. Please eat well and take care of your health. Thank you. Thank you so much. That means a lot to me. Simply in love with your teaching, sir. That's really appreciating. And today's homework is you please go through the classroom practice questions. Please try to solve classroom practice questions. So now these are the conditions that we have been discussed and now you please go through this one and tomorrow we'll be solving much more questions and I'm going to tell you much more logics also. So don't worry about that. Class is good. Your explaining concepts are great. This comment, sir, you have so much of patience towards us. So thank you so much. So thank you all of you for your comments. Yes. So yes, I have written GATE only once, and in the first time only I got that rank, and later on I did not. I love you, sir. Thank you. Love you all. Is it possible for you